Hey guys, in this video we're going to learn about abstraction, which is a principle of object-oriented programming. Now, what if I tell you that users of your class cannot or should not care about something, how it works, or only what it does? For example, you go to an ATM, you don't need to know how the mechanics of an ATM works so that you can withdraw money or deposit money. Okay, it's you are unaware of it, and that's completely okay. You are still making use of it to complete your task. Now, another example would be you have a car, and you as a driver are not a mechanic, so you don't actually need to know how to how the mechanics work, how the engine works. Okay, you just push the key and turn it, or if it's an automatic car, you just press the button and the engine starts running and you go forward, right? So you don't necessarily have to know how the mechanics work, but you still make use of it. Similarly, abstract methods are just the same. So abstract methods in Python are not by default supported. So what we do is we import a class called ABC, okay, a base class, and we use its method so that we can implement abstraction in Python. So I have a program right here which explains why we need to use abstract methods. Now notice I have not explained or written anything about abstract methods right in this program. This is a very simple program and it just basically tells us why we need to use abstract methods. So we have a class payment and a main method, and we are using the definition payment, which is inside class payment, to call that using an object that we have created in line 13. Okay, now we are passing a parameter, a string parameter called credit, to the payment type in pay definition. Okay, and we are using that payment type and checking whether what type it is, and based on that we are printing the processing statement. Okay, and if it is none of these, then it just says invalid payment type. Now I just read out the entire program in front of you, but what it is actually trying to do is it is just checking whether payment type is what type. Okay, and this takes a lot of time. So say supposing you have a teacher and a student, and the teacher asks a student, what student are you? Are you a math student, physics or chemistry student? And the student says that I am a math student, and the teacher solves all those math problems for that student. So that's unfair, that's not cool, that's not how things work. The teacher provides the work for each student so that the student can do it, right? And the students learns from it. So the problem here is that the teacher is doing all the work. Students have no responsibility. If a new subject comes, teacher must learn and update. So this is that code. Okay, so payment type is being updated every single time for checking this uh, parameter. Okay, now say what if it was PayPal? Then it would first pass through credit, it would then pass through UPI, and then finally to PayPal. And if it was none of these, then it would have to check through all three. Okay, so payment type and right here pay definition or pay method is having to do all the work. Okay, which is not how it's supposed to be. So to solve this, we include abstract methods, which means that we just create another abstract method. Okay, and we tell that method that this is a common method, and you will be overwritten by other methods to perform the task that you want to achieve. So this program is very loosely structured. There are no rules, just anything goes. Okay, and the teacher student kind of example was more like a Eli 5 version or explain like a 5 version. And abstraction here comes to the rescue, saying I don't care what you are, just make sure you know how to do the job. So if there was an abstract method, I'm going to convert this entire program into an abstract using abstract methods, and I'm going to see how it works. So okay, so I'm just going to shift to say the main method right here. Again on this one right here. Now we have multiple files imported: cash payment, credit card payment, and UPI payment. And we have multiple objects here, and each object is responsible for calling their respective uh, pay methods in their respective classes. Okay, now I'm going to open the payment file, which is an abstract class, which contains an abstract class. And how I can tell you that it's an abstract class is because, first of all, we are inheriting the ABC class, okay, which is an abstract class. It stands for abstract base classes, okay, and it contains the abstract method, which we use as a decorator to declare that this method called pay is an abstract method, okay, and class payment contains an abstract method. So this payment right here is called an abstract class. Now class payment is inheriting ABC, which is an abstract class, and abstract method is being declared. So we know here that in line 6 that this pay method is an abstract method, okay, and abstract methods don't have a body, they only have a declaration, okay, no definition. Having a definition means that method has a body. So in this method we don't have a body, we just call pass. That means it just skips that method, and by skipping this method it means that uh, say this pay right here is a teacher, and pay right here is the student from credit card payment or math subject, for example. This pay method is from a chemistry subject, cash payment. Okay, I'm just giving an example. So method declarations, that is pay method, are using pass keywords, okay, which means that they are abstract methods. It doesn't have any body. And payment is an abstract class, and pay method is an abstract method. So we are using this pay to override by different classes, which I'm going to show you as cash payment. Okay, and I'm going to open this to the side. These are all subclasses of the class payment. Okay, okay, this is subclass 2. I'm guessing this is subclass 1. So in subclass 1 we are inheriting the payment class, okay, and by inheriting the payment class we can access the pay method right here, okay, which is an abstract method. And on inheriting payment by accessing pay method, we are basically overriding that method, okay. And I have previously explained what method overriding is, and we are using that same uh, method overriding in this program as well, okay. So pay method right here is going to override the abstract method, okay, and the abstract method here has no body, so we are writing the body for the abstract method right here. So the student, which is in credit card payment class, is doing the work for the teacher that has been assigned, okay. The abstract method has assigned a few tasks, and saying that I have a pay method and I take a particular amount as a parameter, okay. And what the student is going to do is that pass that parameter as the user provides, okay. Like in the main method right here we are providing a parameter which is 500. So for credit card payment we are passing 500, which is being received by the amount parameter right here. Receive that amount, and it says, it prints out paid so and so amount using credit card. Now similarly, cash payment is doing the same thing. It's another subclass of uh, the abstract class, that is payment, okay. And similarly with UPI payment, it's another subclass of the abstract class payment. It is just basically overriding the pay method. And one thing, a very important note that is to be seen here, I'm just going to run this, and we are in payment app, okay. Run the main, okay. We are passing 500 right here. We're passing 500 in credit card, 300 for cash, and 1200 for UPI, okay. Now say for example if I do this, I'm just gonna, okay, I won't clear this, let it be as it is. I need to say close this, okay, and this as well. Now say if I create an object of this abstract class, I will not be able to, it's going to give me an error. Okay, so I'm just going to try doing that. Although we can have an init method, okay, but abstract classes don't allow us to create objects. Okay, say I have pay, so I'm going to create payment dot name of the class is payment, uh, okay, and like that I'll use payment object to use the abstract method pay to pass 1000. Okay, and payment is not defined. Okay, I'll just import payment right here. Like that. Okay, I think it was small. This is the name of the file from name of file import so and so class. Okay, so the name of the file is with small p, it's not capital, and the name of the class is capital. In Python, name of the classes should always be capital, and just like that we are passing the parameter 1000. Now say if I run it, it's going to show me an error. Okay, and it says that type error, can't initiate abstract class payment without an implementation for abstract method pay, which means that an abstract class is incomplete by design. Okay, I'll just open this payment class and show that it defines a contract. A contract means what methods must exist. So it does not provide full behavior. This method, abstract method pay, does not have a function body. Okay, it's just being declared, and other classes are just inheriting that and overriding it. So creating this object makes no logical sense. Okay, what would payment.pay even do? It doesn't have a definition, so there is no implementation. So we cannot create objects of an abstract class because it may contain abstract methods without implementation. So instantiating it would result in an object with undefined behavior, like we can see here, without an implementation for abstract method pay. So abstract classes are meant to be inherited, not instantiated. Instantiated means to be created. So this is Python's way of enforcing discipline on abstraction. So I'm just going to remove this just in case and run it again. Alright, so abstraction isn't about hiding code, it's more about setting a rule where every object has to do their job properly. That way your code doesn't turn into a mess when things grow into larger scalable projects, okay, with real code bases. So that's it for this video. In the next video I'll be covering more on what encapsulation is with real code examples. So keep practicing and I'll see you there.